Okay, guys, go to page 27. I want to talk about a couple of things I noticed as I was creating the quizzes. I think really the biggest issue that I saw was the parent graphs not having that table set correctly for parent graph, and that ended up just throwing off a lot of your answers. So if you guys can find any room on your packet, I just want to just make sure that we can get these memorized so that we don't make these mistakes on the test. So parent graph. Okay, parent graph tables. Again, just find any space that you can in your packet. Any somewhere between page 26 and 27 where our test review is, or maybe even 25, 24, if you can find any space or on any separate sheet. So first is sine. And I'll put in parentheses cosecant. Okay, so let's make sure that we understand sine and cosecant are the ones that are reciprocals of each other. And it's not, cosecant and cosine, right? So those are not. Cosecant goes with cosine, cosecant goes with sine, right? So, now with sine, you're always going to start at 0 and you're always going to increment by whatever your interval is. Remember your period formula is 2 pi over b, and then your interval is b over 4. And you're always starting at 0 and you're always incrementing by that value initially. And you guys were doing that fine, no issues. And sine starts at 0, rises up, and then back to 0. Okay, I didn't see any issues here. The only thing I saw was some of the students got cosecant mixed up with what the relationship was. I think some people were doing cosine with cosecant. Okay. But for the most part, I didn't see any issues there. Okay, so the second big one is cosine. And cosine is with secant, right? We're also building the same table with secant, but we know that everything's in the background, and we have to just create these parabolas that live above and below the peaks and valleys of our cosine curve, which again, I didn't see many issues with that. But let's make sure that we understand with cosine, again, this table with this 5-number system. But here, and again, you're starting at 0, and then you're incrementing your way through using your interval and your period. And you guys were good there. Okay, cosine starts where? 1, right? Starts at the peak, makes its way down to the minimum, and then rises back up to that same point. Okay, by and large, I think we're okay there. I think the only big mistakes that I saw with cosecant and secant is just building that domain, building that vertical asymptote. And we'll go through a few examples today, but it seems like when we were doing practice that you guys are getting better with that domain. After you find that first vertical asymptote, you just do that value plus, and then whatever the width is between any of the asymptotes, it should be the same width every time. And then it's the width times whatever that n, width times n. Okay, so the third is cotangent. Okay. Now cotangent has a different period, right? Period is just what? Yeah, just pi over b. Right, and your interval is p over 4. Okay. Theta, 2, 3, 4. Now, where does cotangent start? Also with a 0, right? And I think that's where I saw some students make mistakes. Cotangent actually starts with 0, and then you increment your way through. Tangent is what starts in the middle, okay? And is cotangent, is that graph rising or is it falling? It's falling, right? So vertical asymptote on both sides. Because it's falling, we want to start high and work our way low. And last one, tangent. Tangent has the most changes. It kind of looks like cotangent, but what's the big distinction in how we build our table? 0 starts in the middle. Now, one thing that I saw was, I think some of you guys were trying to get that 0 to show up at the end of the problem. You want to build that 0 at the beginning of the problem. And then whatever the phase shift is, just let it take its course. 0 may not be involved anymore in the middle, but that's how you want to begin. You want to begin 0 in the middle and then subtract your interval, add your interval, subtract to the left, add to the right. And then whatever the phase shift does, then just let it take its course. But you want to begin at 0. I think some of you guys were trying to do too much. You were trying to figure out what the phase shift will be so that it will end up with a 0 in the middle. And I think that's what threw the course of your problems out. Okay. Tangent theta, vertical asymptote. And what's the difference with the slope pattern here? It's increasing. So we start low and we rise up. I think some of us got a little thrown off here, either with organizing the x values or determining that, or getting these two confused. Basically, that's basically the big thing that I saw. But for the most part, you guys were factoring out that b value pretty well. You were adjusting to that phase shift pretty well. So hopefully today we can kind of just clean those things up for tomorrow's test. Okay. Now, you guys just picked up a test review. I'm not going to do the test review. I'm going to actually continue on with page 27 and try to finish that sheet. I'm hoping that the test review can kind of be your own review. But I will have a morning review tomorrow at 7:30. If you want to come in, we can go through that test review together. Or if you have any questions about anything, and come in, we can go over that. I will send out a Teams link. Okay, so I don't have a Teams page for this class, but I will send out a Teams link through Remind. And if you want to join at home, you can join the review session at home. I'm just going to go over that test review that you picked up, and there's a key attached. So hopefully you guys will be able to work through it tonight, and just understand that's basically what you're going to be expecting on the test. Okay. You can use your calculators, and you have the full period to work on your test question. I'm sorry, domain. Yes, domain and range. Yeah, domain and range will be on the test. So page 27. I think we've got through 1 through 4, right? Hopefully, guys, we all got a chance to check our answer. Let's look at 5 and 6. Make sure we still remember how to create these graphs. Or starting with the graph, create an equation. So page 27, let's work through these two, or let's try to work through the rest of these pages together. All right, so it says write two functions for each graph using the specified functions. We want to target the easier one, okay? And the easier one is the one that this resembles most like without any shift. What does this graph look like to you? Cosine or sine? Cosine, right? Because it starts at a peak, right? Starts at a peak and makes its way down. Now, I want us to highlight what we think the period is. How long does it take for this cosine function to finish its cycle? Yes.
Okay,
Go ahead. Power 2. So here I'm starting at the peak and I'm ending at the peak. So I know that I've completed a full cycle because anything after it, we'll just kind of repeat that same process, right? So we want to understand this is not pi being, right? If we think pi is a full cycle, then we can see that it's already gone through 2 full cycles when it reaches pi. Okay, so let's start with cosine first. So our period is power 2. Let's find our b value. Okay, b is equal to 4. Okay, where's the center of this graph? What's our d value? Can you guys tell by looking at the graph?
Close one.
Plus 1. Okay. Can you guys tell what the amplitude is? What is the a value? 2 from rest to crest, right? So from the center to the peak should be the same distance as well, right? If I count from the center to the minimum, it should also be 2, and that is the case. So I know that a is 2. And because we're starting with the easier one, we know that there's no phase shift. There's no need to worry about a c value. Okay, so I don't have to really worry about that bracket there. I could just leave that out. There's no need to factor a 4 out really, because my c is 0. So, okay, so that's the easier one. Okay, are we okay with cosine? Yes.
I just know that D is 1.
How do you know d is 1? So d is going to be the center of your graph. So if you can kind of imagine this graph, we know that 0 is no longer the center, right? So if you look at this graph, you can kind of tell that the center of the graph is right at 1. Right? Because from here, it rises up 2 to reach its max, but it falls down 2 to reach its minimum. So if I can find that center, that where I can see that same distance from the middle line to the peak as it is from the middle line to the minimum, I know that I've reached my b value. Does that make sense? Okay, right. Right, because if you pick any other d value, you're going to see that it's going to be kind of off balance, right? You should be able to have the same distance to reach the peak as it is from the center to the minimum. All right, so now the more involved one is the sine. Okay, and the sine, we really need to kind of create the sine graph that is close, but not exactly what this graph is. So if I want to create a sine graph that kind of has the same amplitude and d value, where would you start? Where would you start your imaginary sine graph? Would you start at 0? Start at 1, right? So we know that our sine graph starts at rest and then it rises. So you're going to kind of just create your sine graph. It's nice to have a visual here. We know it's going to rise up to this peak. Okay. Back down to its rest again, down to the minimum. Oops, I'm sorry. This graph is a lot more condensed than I was giving it credit for. So it goes here, center, because it needs to complete its cycle in pi over 2, right? So there's my sine graph. Let's create the equation for the sine graph, and then we can worry about how, in which direction we got to move that dotted line so that it'll line up with the cosine graph that is showing. Okay, but a lot of similarities, right? The sine also has an a value of what? 2. Also a b value of 4. Parentheses theta. Also a d value of 1. The only thing is to have to worry about what that c value is. Now, how many clicks do we have to move it so that it will line up with the solid graph? Take the dotted graph and move it in which direction? Left. And it's exactly one interval over, right? So I need to move the graph left one interval. Now the interval is not very clear, so is there a way for us to find what that interval is? Got formula, right? What's our formula for interval? E over 4. We have our period, which is pi over 2. Dividing by a number is the same thing as multiplying by the reciprocal. So the interval is not easy to see, but if we have the period, we can always find the interval by just going through that formula, right? So we got to go left by one interval, which is pi over 8. So how do you represent left one interval? We're going to say what? Plus, yep, plus pi over 8. Okay. Questions with?
How are you able to plot those points in the first place?
Well,
without knowing.
Without knowing, right? So you know that your sine graph is going to be very similar. It's going to complete its cycle within pi over 2. So I'm just looking at the points that the cosine has. So I know that it's going to rise back to the center, back to the minimum, and then back up to the origin, right? It's got to complete its full cycle in the same time frame that the cosine does. And then because I know that my period for my sine is pi over 2, I can also figure out what my interval is. My interval is just p over 4. So I just know that I'm just going to take my dotted graph and just push it to the left or to the right. In this case, it's to the left. And it's usually with these problems, it's always going to be just one interval over, right? So as soon as you find that interval, you can just push that graph and make it the same graph with one being the shifted version of the other. Yeah, so it's basically always going to be one interval over. And if the interval is not given to you, you have the period, you can always find the interval. Okay, so let's try number 6. See if we can work through this one. Okay, I think something that helps with this problem is trying to figure out where that d value is. Where's the center of this graph? Can you tell? -2. So if you look at this graph from the perspective of that d value, -2, what does this graph look more closely aligned with? Does it look more like a sine graph, or does it look more like a cosine graph? Sine, because sine starts at the midline and works its way out, right? So this is what my full cycle for my sine graph looks like. Starts at the center, or starts at the midline, rises up to the peak, midline, back down, back to the center. Okay. So we're going to start with the center. I'll start with the sine first. Okay. What's the A value for my sine, for the sine graph that I see in front of me? Four, that's the distance from my center to my peak. Okay, A is 4. In order to find the B value, I need to figure out what the period is. How long does it take for this graph to complete one cycle? 4 pi, right? So here we see that one cycle is going to be completed in 4 pi. Now we're going to work our way back, try to figure out what the B value is. Okay. What can I do to solve for B? Divide both sides by 4 pi. Okay, so B is equal to 1/2. C value, we know it's going to be 0 because we're starting with the easier one. It looks like the sine, so we know we're not going to have any shifts. And D, we found is -2. Okay. Okay, everybody okay with the sine graph here? Okay, so let's see if we can graph an imaginary cosine graph to help us visualize that. So if I want to create a cosine graph that has all the similar features, where do we want our cosine graph to start? What do you know about the cosine graph? Where's the cosine graph start? Right, usually starts at 1, but we usually start at the peak, right? We know cosine starts at the peak. So what is the peak for this graph? 2. So we'll let it start at 2. Okay. We know it's going to have to make its way down to the center next. Down to -6. Back down to -2. And then back up to 2, right? You know that your cosine graph starts at the peak and ends at the peak. So let's create the cosine graph. It's going to be very much the same thing as the sine, same A value, same B value, same D value. But we have to ask ourselves now, which direction am I going to move this dotted line, dotted graph, so that it will fall into this solid graph that I'm really trying to do? I'll move to the right, because right now that dotted line is slightly to the left. I want to just move it to the right 1 unit. So again, we got to do the job of finding that interval, right? What is one interval? Well, we know what the period is, right? The period is 4 pi. So how can I find that interval? So I know my interval is pi. I know I'm going to move to the right. So what's that going to look like? What's right one minus? Okay, next page. Okay, let's start with number 8. Yeah, we'll come back to 7. Let's do number 8 first. Good. Okay, number 8 says true or false. Every sine function of the form a sine d x minus c plus d can be also written as a cosine function in the same form. And what do you think the answer to this one is? True, right? We just experienced that with 5 and 6, right? That we know that sine and cosine are just shifted versions of each other. I can always write one in terms of the other. And here's one example. Cosine theta is basically the sine shifted to the left pi over 2. That's the parent. Okay, number 9, true or false, and explain why. The period of cosine A theta is equal to 4 times the period of cosine theta. Let's not guess, right? Let's just go ahead and find the periods of both functions, compare them, and see if it will whether that statement is true or false. So separately, let's go ahead and find each of these periods. Right? We have the b values for both. We know the formula is the same, 2 pi over b. Okay, what do you think? Is this a true statement? The period for function f is 4 times that of g of x. Okay, let's test it out, right? F of x is pi over 4. Let's see if this is a true statement. Is pi over 4 the same thing as 4 times? Not the same, right? Pi over 4 is not the same thing as 4 pi. I mean, we can maybe say it the other way around. Maybe g of x is equal to 4 times that. Maybe that will work out. But here, right, if you just take that statement, take what you have, find what you can, insert into that statement and see if it ends up being true. There's no need to guess. We can see that it's obviously not true. False. Okay, number 10. True or false, and explain why. If x equals theta is an asymptote for y equals cosecant of x, then x equals theta is also an asymptote of y equals cotangent of x. Now, what do you know about cosecant? Cosecant, maybe let's make it something more familiar where cosecant is same thing as what? 1 over what? 1 over sine. And cotangent, what do you know about cotangent? It's opposite of tangent, okay? And tangent is y over x, cotangent is x over y. So in terms of sine and cosine, do you know what cotangent is? Cosine over sine. Now, we know asymptote is related to the denominator, right? So you think that cosecant and cotangent will share the same asymptote? Yes, right. Whatever makes sine 0 is also going to make sine 0 here. So cosecant and cotangent, the parent graphs at least, will share the same asymptotes. Because we know cotangent is x over y, right? And we know x is cosine and y is sine. So therefore, cosine over sine. Right, we associate cosine with x. We associate sine with y. Yes.
We're gonna have to do this on the test.
Similar. Well, yeah, there'd probably be like one problem where you're going to have to kind of answer these types of questions. Yes. I'm sorry.
We explain the problem.
Oh yeah, for number 10. So number 10, cosecant is 1 over sine, right? So whatever makes sine 0 is where the asymptote is for cosecant. Okay. And cotangent is cosine over sine, right? So whatever makes sine 0 is also where your cotangent will be experiencing 0. So we can kind of, we can cross out 11. I kind of show you this in full detail, so you kind of be convinced that they are going to share the same asymptote, right? So we know that cosecant is related to sine, right? And let's just build out what we know about sine graph. All right, so sine looks like this. And then we know the original sine graph is period is 2 pi. Interval is pi over 4 period divided by 4, which is pi over 2. So just to show you what sine looks like, we know sine starts at 0, goes up to 1, 0, -1, 0. Now for the cosecant graph, where are the vertical asymptotes lining up with? Wherever there's a what? Wherever the graph touches the midline, right? So we know vertical asymptote is here, here, here. Likewise, let's see what we know about cotangent. Cotangent has a slightly different period. Period is pi over b. We know the parent graph is just pi over 1. And the interval is period divided by 4, right? Pi over 4. Cotangent starts at 0. And then we build out pi over 4, pi over 2, 3 pi over 4, and pi. Okay, what's the pattern that we memorize for cotangent? Okay, but what happens at the end?
Oh,
It decreases, right? So 1, 0. You see these asymptotes lining up here? It decreases, right? We know there's no vertical asymptote with the cotangent graph. It's only at the ends, right? But for cosecant, we know that it's built off the sine, and wherever the sine is 0 is, we know that those are the asymptotes that will get dropped.
shift.
Sorry?
Wait, to shift the cotangent because it's asking for 0 to 2 pi.
Oh, sorry, this is not, this is, yeah, we're crossing on number 11. I was showing this from number 10. Yeah, because you're asking for explanation for number 10, so I was working that out down here.
Okay.
Give me 1 second here. Okay, so your test tomorrow will be similar to what you saw with this, test review that we went through. And also you can kind of use this, the sheet that you picked up as kind of helping you see what to expect. So you will get 4 graphs. Most likely one of sine and cosine, one of secant and cosecant, and then one tangent and one cotangent. Look at number 3 and 4, see if you can work through that. And then you'll also be having to do problems where you have to be able to write a trig function in terms of sine and in terms of cosine. So everything that we've quizzed over, pretty much what to expect on the test. Yeah.
What be horizontal stretch?
Will be a horizontal stretch.
Like, if we're gonna be asking for that.
Yes. If I ask you for transformations, you just have to look at that b value, right? And whatever is in the denominator, it's going to be a little bit, yeah. So, go ahead. So b is greater than 1. There's going to be a horizontal compression. If b is less than 1, there's a horizontal stretch. All right, so for instance, if I have y is equal to, let's say 4 secant of 4 theta minus 6 plus 5, then what would you say? It's a what? Compression, right? So you'll say horizontal compression. That's right, by 1 4.
Are we gonna have to write out the transformation?
You're expected to, yeah. So anything that you saw on the quiz, you can see that on it, but there's going to be nothing new between the quiz and in terms of concept. So if you can do the sheets, you should feel good about your test tomorrow. Again, I will have morning review at 7:30 in the morning tomorrow. So I'll send you guys a link. You can also come join it in the classroom.